Today we want to talk a little bit about the test for independence and our Excel number 4 project. What this is based on is our contingency tables that we took a look at a long time ago, way back in chapter 4, section 4, and it was also a project in your number 1 Excel. And what we did in that one was there was a question about purchasing likelihood versus age groups. And so we had this set a chart there, and we calculated all the row columns, and then we calculated all the total columns, totals by age group, totals by likelihood. And then we computed the relative marginal frequency for each row. In other words, we took the number in the box and divided it by the total for that row. And after we did that, we took the relative marginal frequency for the column variable. So we took the number in each of the boxes, each of the cells, and we divided it by the column total. So what we're going to do in this test for independence is something similar to that. We're going to start exactly the same way, as a matter of fact. And then we're going to use the expected count concept for the proportion totals for each cell. Let's take a look at how we're going to do this. We're going to compare the expected and the observed accounts, like we did with this chi-square goodness of fit test, for example, when we did the M&M example. And as a general result, we're going to have the expected frequency to be equal to the row total times the column total divided by the table total. And we're going to use as our test statistic the same one that we've been using for the chi-square. That is, chi-squared is equal to the sum, that's that Greek letter symbol, sigma there on the bottom row. Chi-square is equal to the sum of the observed value minus the expected value for each data point, that's the sub I. Quantity squared, that gets rid of the negative sign, divided by the expected value. And when we do our critical value, we're going to use the degrees of freedom of the number of rows minus 1 times the number of columns minus 1. So our chi-square test for independence is in the same 5 steps, that we've been doing for all these hypothesis testing, starting with step 1 to write down the null and the alternative hypothesis. In this case, the null hypothesis, H naught, colon, the row and the column variables are independent, compared to the alternative, H1, the row variable and the column variable are dependent. So back on that 4.4.7 Excel problem, is the purchasing dependent or independent of the age of the customer? Step 2, we're going to calculate the test statistic. Before we actually get to that, we need to calculate the expected count for each cell in the contingency table. And what are we going to do there? Just what we had on the previous slide. See it? The expected is going to be the row total times the column total divided by the table total. Now the conditions we can satisfy, simple independent samples and so forth, like always. Okay, so now we're actually ready to compute the test statistic. And what are we going to use? We're going to use that chi-square test statistic, the sum of the observed minus the expected, quantity squared, divided by the expected. Pretty easy to do in Excel because you've got 12 cells, and you've got to take the 12 observed cells and the 12 expected cells, take the difference, square it, divide. Excel makes that pretty easy, really. So step 1, state the null and the alternative hypothesis. Step 2, compute the test statistic. Step 3, we're going to determine the critical value. In this case, we'll use an alpha of 0.05. And then we're going to look that value up in the chi-square table. For our degrees of freedom, we're going to use the number of rows minus 1 times the number of columns minus 1. So in this case, it was 3 and 4, so we'll use 2 and 3. 2 times 3, we will use 6 degrees of freedom. Step 4, we're going to sketch and compare the test statistic and the critical value. These chi-square tests for independence, like the chi-square test for goodness of fit, are always done as a right-hand test. So If the test statistic is in the critical region, we reject. If the test statistic is further away from the middle than the critical value, we reject. Same concepts as we've used before. And in this case, rejection means what? Rejection of the idea that they're independent in favor of the hypothesis that the rows and the columns are dependent. And then, again, like always, if the test statistic is not in the critical region, we do not reject the null. Not in the critical region, not reject the null. And we're going to state our conclusion, which has to do about whether we accept or, I'm sorry, we never accept, whether we reject or fail to reject the null hypothesis that the two variables were independent. So our rest of chapter 10, we have a homogeneity of proportions, which also uses the chi-square. That would have been pretty handy in that one example we had a couple sessions back with the flu shots at the nursing home, because there we had 4 proportions potentially, right? We had got the flu shot, did not get the flu, got the flu shot, got the flu, did not get the flu shot, got the flu, did not get the flu shot, did not get the flu. So we had 4 proportions, and this would be a handy way to see whether anything was different from the other ones, especially compared to previous results. All pretty interesting, but something that we're not getting on the final exam. So what we want to take a look at then is our 4th Excel project. We've got a couple different problems with this one. The first problem is 11.2.18 on page 546. You're really only doing a couple of parts, which is you're going to test the researcher's question at the alpha equals 0.05. And it has to do with airplanes and whether you should let the propeller windmill or whether you should keep it locked down if you lose engine power. So you're going to state the null and the alternative hypothesis. You're going to do the find the critical value, compare it to the test statistic, and then write your recommendations to the pilot. The second question is a goodness of fit question, chapter 12.1. We're going to use as our problem data the Wendy's problem that we used in both the second and the third Excel. So what you're going to do is put that formula in. What formula? What formula? This one down here at the bottom of the page, the test statistic. You're going to take the observed minus the expected. You already drawn a graph about that. You're going to take that number and square it, divide it by the expected, and then remember in the Wendy's we had anywhere from 0 to 16. We're going to add all those numbers up. And we're going to put that sum of all those numbers in some cell S12. By the way, that's going to be 80.7 should be your answer. If you don't get that, you've got it wrong. And then you're going to answer the question in the yellow box. The next Excel project is just what we had started talking about, the contingency table revisited. So go back to your first Excel project and pull in that 4.4.7 problem. Paste it in. Analyze the problem again based on what we just talked about the independence, and then put your summary of the analysis in the text box that you're going to create somewhere near cell J3. The next part about the Excel project isn't an additional problem, but as we've gone through the semester, we like to have an increasing awareness of how Excel looks. So we've started titling our sheets to make them correct. And then this one, what we want to do is make sure it looks as good as possible, like a professional business report would work. So we want to use business appropriate fonts. You may have to hunt down some party fonts and get rid of them and switch it over to something more business-like, like Times New Roman or Arial. And then we want to get rid of the Qt graphics. It's cute, you know, pictures of cute little cats. That might be fine for your Facebook page, but it's not appropriate for a business report. So get rid of any of those things. So when you've cleaned up the report or your project all the way, you do what we've always been doing, which is we save it to an save the file, attach it to an email, and email it to me with the subject line being your name and Excel number 4. statistics. Now let's take a look at the actual Excel sheet. This is my answer key, but that's okay. Not just, it looks, your template will look similar. Sheet number 1, the instructions, just like always, you can read through those before and after you've finished, and that'll tell you what you need to be doing. The first sheet after the instructions, there it is a sample problem on how the match pair actually works. So you can study this one and see exactly how it is that you're going to do the actual test problem. There's nothing you have to do on this sheet, just study it so that you know where you're going on the next one. And so here's the next one, 11.2.18. Like I mentioned, it has to be windmilling the propeller or stopping the propeller. And so you want to state the null and the alternative. You want to conduct the appropriate test. And in the previous sheet, you saw there was 2 different ways to get that. But you can see here I've got the hypothesis. There's where I did the test. There's where I stuck in the answer that talked about it. That's what yours will look like. Next one is the good fit Wendy's. This graph right here looks familiar to you already. Now what you're going to take a look at is these right in there. You're going to take the original minus the difference, which is the same numbers that you got for that graph. You're going to square that and divide it by the expected. And you're going to get that whole series of numbers there in row 10. And then in the box as predicted, you're going to put the sum of those numbers in there, and it should total 80.7. Then you're going to go down here and compare it, and you might find some other stuff in that Excel sheet. And then finally, the contingency table, to refresh your memory, here's what it was. There was where we were totaling the raw and the columns and the data. Then we collected the different kinds of frequencies and did them in there. And then there was a set of graphs. Yours should have looked like that one there, with the 4 different age groups across the bottom, with the more likely, less likely, or not neither one on likelihood to buy. Some people had them flipped upside down, in which case your graph looked like that. But for the purposes of this problem, it didn't matter which way you did it. So that pretty well concludes the Excel project.